We're back again, and we're looking at earthquakes today. So we looked at different types of plate motions yesterday and did our CER. So we're going to look at kind of like a model of an earthquake here. So we have two pieces of styrofoam, and I'm trying to set this up so you can see this good. So we got two sets of styrofoam here. We've got cups of water in each one. And we're going to kind of like look at what happens when we have the different types of plate motion. So if we have the plates where they pull apart, you can kind of see, if you look to the top of the lid here, or not the lid, but just the opening, you can kind of see the water move. So I'm going to shake that one. You can see it moving, right? And if I shake this one, you can see it moving. So if I just move them across, there's a little bit of shaking, and that would be kind of like having a little minor earthquake. The plates are moving, so it does make some of the surface things kind of move. If we kind of push these together, and I kept pushing them, so let's try doing this, something like this here. So say we had one plate going on top of the other, and it kind of moves. You can kind of see the one that's moving is still shaking here. See, if you look at the edge right inside the cup here, you can kind of see the water level moving. So here we go again. So you can kind of see that it's moving on the inside. So anytime the plates are going to move, especially against each other, they're going to do that. The one that really makes the biggest motion is side by side when they pass each other like this. So again, take a look at the water levels here. If you can see the inside, the top, that's great. If you can see the side part here, you can just watch there. So I'm going to kind of push these together. I just don't want them like drifting off where they want to. So I'm going to push them together, and you can see right down the middle that this is not smooth. It's nice and rough. So I'm going to kind of push them together, and I'm going to push this plate this way. And just keep watching what happens with the water levels on the inside. So you can see the bumps are kind of making it hit, and then it kind of skips. And every time that happens, once I build up a little pressure here, and I try pushing it, it doesn't want to go until I get enough pressure and then it slips. Every time that slips, I get a little shaking. So anytime the plates move, we're going to have a little earth shaking a little bit. And that earth shaking is going to be an earthquake. So that's just a little demonstration so you can actually see that, when these plates move and they kind of slip past each other, they kind of get stuck, and then they kind of slip. And with that slipping, that's when we get our earthquakes. So that's just a little quick demo there. The rest of our class was working on another CER. So I'm just going to get the... So we worked on another CER, and this time it's about explaining earthquakes and the plates. Just going to adjust this here a little bit. So we have our claim. The claim's already on your paper. So it says earthquakes are caused by plates moving past each other and getting stuck on their rough edges, then snapping out of it suddenly. So that's what somebody's claim is. They said that this is what causes earthquakes. So maybe this makes a little more sense. We kind of rephrased it. So the person is saying that plates moving past each other and getting stuck and then slipping causes earthquakes. So if that makes a little more sense to you, it's the same thing. It's just kind of doing the last part first. So that's the claim. We don't have any proof. We don't have any evidence for anything. Person is just saying that. What could we do with what we just saw? So that observation you just saw could be evidence. The things on our chart from yesterday. So if you want to go back to yesterday's video, you could take a look at that and see what the chart was. So then we want to explain why we think that plates moving past each other and getting stuck would actually cause an earthquake. The evidence you can use here would be the demonstration you just saw with the cups. It could be the models from our diagram yesterday from the chart. So you're just trying to figure out you're trying to find out if plates with rough edges on them, on the edges, would cause earthquakes. So we're looking at a situation like this right here. So these are the plates with rough edges. The claim says that earthquakes are caused by plates moving past each other and getting stuck in the rough edges. So what evidence do you have for that? And again, you can use that demonstration as your evidence. And then explaining how that evidence down here, let's get this camera set up a little better. So how the evidence down here would help you explain why they would cause an earthquake. One other thing we pointed out was some people, they want to put everything in one box or the other, because that's the way we've been kind of taught to answer something. We'll say, you know, something, something, something because something, something. And what I pointed out in class today was anything before the word because is your evidence. Anything after the word because is your reasoning. So let's just try something with non-science. So I got a 78 on a test. That's evidence. That's just my score. So what you might say is, I got a 78 on my test because I didn't study. But you're doing two things there. You're saying, I got a 78 on my test because I didn't study. That's the why. So if you're having trouble doing the reasoning and evidence, it might be because you're trying to answer both things in one part. If you're saying something, something, something because something, something, you're doing the evidence because the reasoning. So if that helps you kind of distinguish what you're doing, so you may want to just write a sentence out, maybe on a scrap piece of paper, write out what you want to say, and then look for that word because, or this is why, or my reason for. Anytime you use those words, that's your reasoning. Evidence is just facts. The facts are not going to explain anything. The facts are just going to be things you can use to explain. Okay, so this will be in the download area. So download that, send it to Notability, and then answer those. You're not trying to come up with any brand new ideas. You're just trying to explain how that model might explain why these rough edges on plates might cause an earthquake. So that's what you have to do for today.